So our next lesson here in Unit 2 in 930 is going to be about graphing lines. So we've talked about intercepts, we've talked about slope. So now we're going to kind of put some more pieces together and see if we can't find a pretty quick and easy way to graph an equation of a line using a couple pieces of key information. Now the easiest way to graph an equation of a line is if this line is in slope-intercept form. Slope-intercept form is one of the most important formulas I think that you will honestly learn this year, one that you need to remember and memorize, but I promise by the end of this unit you will know it by heart and you will never forget it. Some of you may know it already, but if you have not, if you don't know it, slope-intercept form is y equals mx plus b. So y equals mx plus b, where m is a placeholder for a certain number and a key information about our graph, and so is b. So y equals mx plus b is our slope-intercept form. M is a placeholder, and M stands for slope, which hopefully you know from the last couple of lessons, right? M always stands for slope, and so B will stand for our y-intercept. And we know what the y-intercept is already, right? The y-intercept, that is where it crosses the y-axis, and our slope is how steep the line is, right? And if we know those two really important pieces of information, it's really easy to get a good idea of what that line would look like on the graph and know exactly which line we would be talking about. So y equals mx plus b has m for slope, b for y-intercept, hence why we call it slope-intercept form, right? Slope and intercept are the two things that are included in that equation. So let's talk about then, how do I use slope-intercept form in order to graph a line? So let's say that I just give you those two really important pieces of information. What if I give you the slope, m equals -2, and I give you the y-intercept, b equals -5? And it's not even in an equation right now, but if I just have those pieces of information. So if I know that b is -5, this is where I'm going to start my graph. I always like to think of it as begin with B, right? B is always, again, this is the y-intercept, so it starts on the y-axis. So we're always going to start our graph right here on the y-axis. So here it says that I'm starting at -5. So my y-intercept is at -5. So I'm going to put a point right there on the y-axis at -5. And then I'm going to use my slope next. So my slope, again, that we've talked about the last couple of days, slope is always rise over run, right? So rise over run for slope. And in this case, my slope is -2. Now that doesn't have a rise and a run, but remember, if I ever have a whole number, I can always put it over 1. If there is no run, put it over 1. That's what I always remember, right? So I can say if my slope is rise over run, it's -2 over 1, which means I need to rise a -2. So I'm going to go down 2, and I'm going to go from my y-intercept, right? Because that's on the line. And then I'm going to run +1. So my next point would be right there, down 2 and right 1. Right? Now, I ran out of graph, and that would be kind of tricky to graph with just those 2 points. We always want to have as many points as we possibly can on our graph. So in this case, then, I might have to go backwards, right? This I have it as -2 over 1, but it would be the same thing if I had a +2 on top and a -1 on the bottom, right? All of that would always equal back to -2. So instead of going down 2 and right 1, I could go from my y-intercept again from that blue point. I could go up 2, +2, but then I would have to go left 1 to keep it consistent and having that line go the same direction the whole time, right? So I could go up 2 and left 1 as many times as I possibly can across my graph until I get so many points that I would get a perfectly straight line, and I can use my ruler to graph it and get a nice straight line on my graph. And I do recommend that you guys use a note card or a ruler or anything like that to keep your line nice and straight, and make sure that you draw that line all the way across your page, or not your page, sorry, your graph, as far as you can. No little teeny baby lines, nothing just connecting two dots. We're not playing connect the dots here, right? We want to make a line across the entire graph as far as we can. And then we also know that we want to put arrows on the ends of this line, right? If I have a word problem or a situation where where I know that it doesn't continue in both directions, that would be different. But whenever I just have a general equation or problem like this, I always want to make sure that I have arrows on both ends because we know that those lines go on forever in both directions. So that's how we would take this information, M and B, and graph the line, right? We always begin with B, and then we count our slope from there. So let's take a look at the second one. Now, if you think that you can do it, pause your video and see if you can do it on your own, and then pick it up and see if you got it right. So here my B is positive 4. Again, begin with B, always on the y-axis. So my B is at positive 4. So I'm going to have my point right here on that 4, up, straight up on the y-axis. Now here it says that my slope is 0. So that would mean that my rise is 0 and my run is 1, right? So I could do that, rise 0, run 1. And then again, and again, and again, and again, and again, and again, and again, right? Or I could go the opposite way, right? 0 divided by negative 1 still gives me 0, and I could go this way and go all the way across my graph that way if I wanted to. Or you could remember yesterday when we talked about those two special types of lines, right? When I have a 0 slope, this is what I call, when we use those two short little words, and the 0 slope we called hoi, right? Hoi. Hoi is a horizontal line because it has 0 slope. So I know for sure, I'm going to get my ruler out so I know that I make a nice straight line. Whoops, sorry. And I don't goof that up. So there's my horizontal line, right? Straight across my graph, all the way, arrows on the ends. So remember, 0 slope is one of those tricky ones from yesterday. That's a hoi. If it was undefined slope, that would be our vux, right? Our vertical line, undefined slope. And in this case, our slope was 0, so it was hoi. So be ready for those two. They might pop in here, okay? So don't worry if you get one of those popping up as well. All right, so this is what it looks like if they just give us M and B. But a lot of times they're not just going to give us M and B, they're going to give us the equation of the line, right? And this is why we needed to remember, or know, I should say, what slope-intercept form was. Remember, that's what we wrote on the top of our papers. Slope-intercept form is y equals mx plus b. So when I look at an equation like in number 3 here, I have y equals negative 1/4 x minus 1. Well, those two things in those specific spots, right? Y equals, here's where my m is. This is my coefficient of x. That's my slope. And then b is down as here at the end. Now it says mx plus b, and since this is negative, it says minus 1, the only way that I would get that is if this was plus, whoops, meant to write it here, right? This would be plus negative 1, right? So whenever you have that a negative number at the end of your equation, that's going to be a negative b. So if I think about this, I say, okay, m is negative 1/4. And this is rise over run, right? And b is negative 1. And again, b is always on our y-axis. Well, now I'm right back where I was, right, on those first problems because I just could pick out the m and the b from our equation. Notice I didn't have, it's not negative 1/4 x as my slope. X is part of slope-intercept form. The m is just the number, that coefficient of the x. So my m is just negative 1/4. All right, so I begin with b. So b is at negative 1 on the y-axis. So there it is. And then from there, I want to count my rise over run. So rise in this case is negative 1. So I'm going to go down 1, right? And then I'm going to run 4. Positive 4 would go 4 to the right. 1, 2, 3, 4. There's my first point. And then I could do it again, I think. Rise negative 1, run 4. I could squeeze in one more. All right, but remember then, I could always go backwards. Maybe that negative sign is on the bottom instead of on the top. So that means I could go up 1, but then I have to go left 4 to continue that same pattern, right? Up 1, left 4. And now I have gone as far as I can across the graph, so I can get my ruler out and I can draw a nice straight line all the way through, and I'm going to make sure that I put arrows on the ends as well. There we go. Okay, so if I have my equation is in slope-intercept form, y equals mx plus b, then I just find those things in those spots, right, in my placeholders, and I know exactly where I'm going to pull things out. So if I look at number 4, again, if you want to try this one on your own, pause your video, see if you can do it. So b would be positive 3 in this case, and m would be positive 1/2. So m is 1/2, and b is positive 3. We always begin with b on our y-axis, so I'm going to put a point up here at positive 3 on the y-axis, and then I'm going to do my rise over run from that point. So rise positive 1, run positive 2, and there's my next one. And I can do that as many times as I can. Up 1, right 2, up 1, right 2, up 1, right 2. Or I could go backwards, right? I've got a lot more graph to fill, so I could go back to my y-intercept, and I could go down 1 and left 2, and it would continue the same pattern. Down 1 and left 2, because 2 negatives make a positive, right? So both numbers could be negative, and it would follow the same pattern. Then I get my ruler out to draw a nice straight line all the way across. There we go. And I've got my graph. Hopefully it's becoming a little bit easier as you go along here. All right, so the next piece of the puzzle is, if I look at my equation here in number 5, 3x minus 2y equals 6, it's an equation, but it's not in the right form, right? I want it to be in slope-intercept form, and slope-intercept form is y equals mx plus b. And this is not in y equals mx plus b because the y is not by itself, right? Here's the y, but I've got all kinds of stuff on the same side as the y. So we practiced this actually last year. We probably did it at the very beginning of this unit, but we also practiced this, not last year, but in unit 1, where we were just getting used to solving our equations, and we were just moving things around. So the idea now is I want to get this y by itself, so that I can get it into y equals mx plus b. Now, in the last unit, all we really cared about is that you could get y by itself. But in this case, I want to put it in the correct order. So I want to make sure that as I'm moving things, y is going to be by itself, but I want to make sure that the x's come right after the equal sign, and all the plain numbers are at the end. So let's think how to do this. So if I'm going to do that, the first thing I need to move is this 3x. I've got to move it to the other side. And in order to move it from one side of an equal sign to the other, sometimes we like to kind of draw our line down, right? If I need to hop over that equal sign, I need to do the opposite operation. In order to do the opposite here, it's positive 3x, so the opposite of positive 3x is negative 3x. So I'm going to subtract 3x from both sides. All right, as I'm subtracting 3x from both sides, they're going to cancel off the left, and I'm going to still be left with negative 2y over on that side. Now, as I can see, I have positive 6 and I have negative 3x. Now be careful. Positive 6 and 3x, those are not like terms, right? One has an x and one doesn't. I can't combine them. That doesn't become positive 3x. Right? They're separate terms. I can't combine, so they're going to stay separate. But I want to make sure that I write the x's first and then the plain numbers. So negative 3x comes first after the equal sign, and then I have a positive 6, so it's going to say plus 6. So again, I do care, right? It does matter, the order. So it says mx plus b, so that's why my x's have to come first, and then my plain numbers after that. All right, I'm getting close, but I'm not quite there. I'm still trying to get this y by itself, and I still have this negative 2 attached to the y. So here, if I think about it, right, negative 2 attached to the y, that means it's negative 2 times y. So to get rid of that negative 2, I need to divide every single term by negative 2 so that I can get rid of it. I can't just pick and choose, right? It's not just on the left and then on the 6. It's every single term, so be careful about that. So if I divide by negative 2, those will cancel, and I will finally have y by itself. Now be careful here, and let's see, negative 3 over negative 2. Well, two negatives are definitely going to turn positive. So I'm going to have positive 3 over 2. And I want to keep my answer as a fraction. Now, I always say, like, you know, how the x is kind of on the top of the fraction right now, but I want to have the x separate, right? Y equals mx plus b. I need to be able to figure out what's just that number in front. So anything like that, I'm going to shove to the front of the x, and the x comes alone, right? So if there's any denominator or numerator, everything's going to get pushed to the front of the x, and then the x will be by itself right afterwards. So I have y equals 3 over 2x, or 3 halves x. And then 6 divided by negative 2 is negative 3. Now again, we don't ever want to write, if I have this 3 halves, I don't want a mixed number, and I don't want a decimal, right? Because remember, y equals mx plus b, it means something, right? M stands for slope, and our slope is always rise over run. And so if I need rise over run, I gotta have a fraction. I don't want a mixed number. I don't want a decimal. That won't help me graph a slope. What I need is a fraction. So I always want to leave it as a fraction. Now, if you could reduce that fraction, we would definitely want to. If that was 6 over 4, we would want to reduce it to 3 over 2. But I don't want to make it into a mixed number. I don't want 1.5. I want one fraction, but I would always simplify my fraction if I could. Right? Always simplify. All right. Now I have slope-intercept form. Now I have everything in the right spot, so I can clearly and easily see, okay, y equals mx plus b. M would be 3 halves, and b is negative 3. So I'm going to write those down. There we go. M equals 3 over 2, and b equals negative 3. So again, I'm going to begin with b on my y-axis. So I'm beginning down here at negative 3 on the y-axis. And then I'm going to count my slope, which is rise over run. So I'm going to go up 3, and I'm going to go right 2, right? Both of them were positive. Positive 3, positive 2. Up 3, right 2, up 3, right 2, and I can't go any farther. But I could always go the opposite direction, just like we had it originally, right? Negative 3 over negative 2. So I could go down 3 and left 2, and that would work as well. And then I get my ruler out here to make a nice straight line, and I can graph my line. Even if my equation doesn't start in slope-intercept form, I can still get there by moving things around with my good solving equation skills. All right, last one. Again, here I see 16 plus 4y equals negative 3x. So my equation is not in slope-intercept form. So I need to rearrange, right? I need to move some things. So I'm trying to get y equals mx plus b. So I'm going to draw my line down, my equal sign, and I'm going to start moving things across. So again, if you want to pause your video and see if you can do it, this would be a good time. So it looks like I need to move the 16 first, right? I'm trying to get this y by itself right here, so I'm going to move that 16. It is positive 16 right now. Opposite of positive 16 is negative 16, so I'm going to subtract 16 from both sides. I get 4y equals, all right, again, negative 3x minus 16. It needs to be y equals mx plus b, so I want to make sure that negative 3x comes first, and then the negative 16 afterwards, right? So make sure you're putting this in the correct order. The x's first and then the numbers, mx plus b. Not quite all alone yet. Gotta still get that y by itself, so I gotta get rid of the 4 now. So it's 4 times y when it's written next to each other. So I'm gonna divide every single term by 4 to get that y alone. Negative 3 over 4, can't reduce anything. I have a negative, so it's going to stay negative. I don't have two negatives, right? So negative 3/4 x, negative 16 divided by 4 is negative 4. Y equals mx plus b. I got it. So here then my slope is negative 3/4, and my y-intercept is negative 4. M equals negative 3/4, and b is negative 4. So I begin with b on my y-axis, so I'm going to go down here to negative 4 on my y-axis, and then from there I'm going to count my rise over run. Rise this time is negative 3, so I'm going to go down 3. Run is positive 4, so I'm going to go to the right 4. Oh, and I ran out of graph already, right? So I've got to go the opposite. So my negative could be down at the bottom. So I could go up 3, 1, 2, 3, and I could go to the left 4 for negative 4. That would work as well. Looks like I can go one more time over on this side to get a nice full line all the way across. And line it up and draw my line. All right, that is the basics of graphing an equation, right? Using m and b, but more importantly, using slope-intercept form, y equals mx plus b. So if our equation has in y equals mx plus b, we just pick that m and the b out. If it's not in y equals mx plus b, we rearrange our terms using those inverse operations until we get it in the right form, and then we can pluck that m and b out to graph our line.